Hi and welcome back. We're going to take a look at partials. So the first thing we'll need to do is actually import it. So the partials function is a higher order function and it is in the functools module. It's a higher order function. Why? Well, it takes in a function as one of its parameters. That's a higher order function. So from functools import partial, and let's just do the example that we did in the lecture. So let's say I have a function which takes in 3 parameters, and all I'm going to do is just print A, B, and C out. Okay, so I'll print that. So if we call my func 10, 20, 30, we just get 10, 20, 30. So we can reduce the number of arguments needed to call my func by essentially specifying one or more of its values ahead of time and then using those values plus whatever additional values need to be passed in. How might we do that? Well, we can say define f, and f is going to take, let's say, x and y as 2 parameters, and this is going to return my func, and it's going to pass in 10 for A, it's going to pass in x for B, and y for C. So now we can call f 20, 30, and we get 10, 20, 30. Or we can call f 100, 200, and we get 10, 100, 200. Right? So we've reduced the number of arguments needed to call my func by specifying a value for A. There's no magic around here. My func still needs 3 values, right? It requires 3 values. We can't get around that. However, we might come into situations where we want to pass my func along to something else, but that something else wants a function that only takes 2 values. And of course, we wouldn't be able to pass my func as is. However, we could pass it f, because f only takes 2 arguments. We'll see examples of that shortly. How else might we do that? Well, obviously you could use a lambda, so you could say f equals lambda, which takes in x and y, and it does exactly the same thing. We don't have the return, of course. It's just going to return my func, x comma y. So now we can say f 100, 200, and what did I do wrong? My func is missing 1 positional argument. Yes, sorry. We need to hard code the value for A, right? Remember what I said, there's no magic? Well, yeah, this is what happens, right? In this case, I still called my func with only 2 variables, 2 arguments. That's not going to work. So let's redefine the lambda, and now let's call it, and now it works as before. So you can certainly do it this way using a def or using a lambda. You can also use the partial function. So how might we do that? Well, we just say f equals partial, and now we need to tell it what callable we're interested in. In this case, I want the function myfunc, and I'm going to pass in 1 value. So that's a positional value, and that's the first positional argument. So it's going to get assigned to the first positional argument of my func. So now if we do this, I can say f 20, 30, and now we have the output 10, 20, 30. Now obviously I could do this. I could say f partial my func 10, 20. That would work as well. So now if I call f, now f only needs 1, right? F is only going to need 1 argument. We get that. If we try and call f with, let's say, 2 arguments, we're going to have an error as well, right? Because what's going to happen is that the partial is going to pass in 10, 20, and then again 10, 20. So we've passed in 4 positional arguments to my func, and my func only takes in a maximum of 3. So of course that will fail. Okay, so you might be wondering, it's like, well, you know, I mean, the lambda really isn't that much more complicated to write or to understand than the partial here. But things can get a little bit more complicated when you have more, you know, esoteric arguments. Maybe you've got a mixture of keyword arguments and you've got named arguments, you know, or you know, positional arguments that you want to pass in as named arguments, or maybe you want to be able to swap around. Maybe I want to specify what should B be, but not, and then pass in A and C. So you start getting into things that get maybe a little bit more complex. So let's take a look. And we saw that in the lecture, so let's try it out. Def myfunc. Let's say it takes A and B and star args, and it takes a keyword value 1, keyword only argument 2, and then we'll take a variable number of these keyword arguments as well. And all we're going to do here is just print A, B, we'll print args out, we'll print K1, K2, and we'll print quarks out as well. All right, so what the function does is simple, but it takes in some pretty complex arguments here. So if we call myfunc, let's say we pass in 10 for A, 20 for B, maybe we'll pass in 100 and 200 as extra positionals. Then we have K1, let's say A, and K2 is B, and maybe we'll pass in a few extra keyword only arguments as well. Let's say K3 equals, I don't know, what should we make it? Let's say 1000, and K4 equals 2000, okay? So when we have that, here we have 10 and 20, which were our A and B, our positionals. Then we had a variable number of positionals that we put into a tuple, 100 and 200. Then we had our keyword-only arguments that had values, the string values A and B. And then we had a variable number of keyword arguments that were returned in a dictionary, that were put into a dictionary, okay? So now let's say that we want to be able to call myfunc, but we want to omit having to pass in A and K1. So we want to be able to pass B, star args, K2, and star quarks, but we don't want to pass in K1 and A. We want to try and basically almost like having a default value for them, right? So how might we do that? Well, we can do that again. We can use a lambda, or we can use a function. We can define a function. We could say def f. What are we going to do here? Now I'm going to use the same names so we don't get confused. So it's going to take in one positional only. It's going to take in a bunch of extra positionals, optionally. Now we don't want K1, we want K2, so we'll take in a single keyword value here. And we want the star quarks as well, okay? Now I can rename them something else. The name doesn't matter. So let me do that, right? So B I'm going to rename X. K2 I'm going to call this keyword like that, for example. Okay, and then star args again. The args really doesn't matter. This could be, vars, and this could be keyword vars. Okay, so we can do something like that. So now how are we going to call myfunc? Well, we're just going to return myfunc. We're going to hardcode the value for A. So I'm going to hardcode it to 10. Then I'm going to pass in X for B. Then I'm going to pass in args, right? So I need to pass args. Then we have the keyword value K1. We need to specify K1. Maybe I'll make K1 equal to A. And then K2 has to be, well, this keyword value there. And then we need the star KW vars. And I just noticed that if I'm going to call this args, then I should call that one args as well, or it needs to call this one vars. Okay. So here we have reduced the number of parameters, of arguments that we need to call myfunc. So now we can call f, and we can specify a value of 20 for what will be b, right? Because this is the first positional argument, so it's going to go into x, but x is being passed as the second positional argument to myfunc. So 20 is going to go into b. Then we'll put in an extra couple of positional arguments, 100 and 200. That's going to go into star vars. That will go into star args, right? Star vars will go into star vars here, which is star args. We need a keyword-only argument, so we need kw equals, here I'll specify b, okay? And then maybe we'll put in a few others. We'll put in k3 equals 1000 and k4 equals 2000. So now when we call that, you'll notice we have exactly the same thing as before. 10, 20, 100, 200 in the tuple. Then we have a and b, and then we have our keyword arguments, our extras, okay? So that's how we were able to reduce the number of arguments that myfunc needs to be called by essentially creating another function that acts as a proxy, right? It puts in certain values for some of the parameters of myfunc, and this way I don't have to specify them every time. Now, of course, we can do the same thing using just a partial. We can just say partial. In this case, what's the function? Well, we want the callable is myfunc. So there we go. And what are we going to do? Well, we need to pass in the first positional argument, which is going to be A. We want to hardcode that to 10, right? So there we go. It's 10. Next, we want to specify K1. Well, K1 is a keyword argument, so it has to be passed in as a keyword, and we just specify it with the same name, right? That name, K1, has to match the name in my func. So when we do that, then we can specify, let's say, a value of A. And we leave it at that. Okay, that's it. So we didn't have to do this whole rigmarole with taking in the vars and x and kw, right? We just said, okay, you're going to call my func, here's the first positional, and here's one of the keyword arguments, k1 equals A. So now if we call f with, well, what are we going to call it? I'm going to call it with 20, so that's going to go into B, because this is going to be now the second positional, because 10 is the first positional. 20. Then we're going to put in a few extra positionals. Then we're going to specify K2, because we already have K1 defined, equal to B. And let's say K3 equals 1000 and K4 equals 2000. And so when we do that, we again get the same result as before. You'll notice that we just have the same thing, right? So it's a little easier, as you can see, using a partial as opposed to using a function or lambda. You could also do this using a lambda. The syntax now is a little cleaner. The next thing I want to show is that we don't have to always specify the first positional in the partial. You'll notice that I've been doing that so far, so you might be thinking, well, it only works by specifying the positional that's in the first place. In other words, I wouldn't be able to specify B without specifying A and then having A being specified later. No, you can. And the trick there is to remember that you can have named parameters. Even though A and B are positionals, remember that they can still be passed in as named arguments. So let's see an example of that. Let's go ahead and define a function called power, or POW, and it's going to take in a base and an exponent. And you'll notice these are just positional. And what it's going to do is return base to the power of exponent. Okay? So now we have this function, and we're going to define a few other functions. We're going to say square, or let's call it sq, equals. So again, we're going to do a partial. We're going to call power, but now I'm not going to specify, I want to specify 2 for the exponent. Now, if I put 2 like this, 2 is going to get passed into the base, right? And if I say sq of 10, I'm not going to get 10 squared, I'm going to get 2 to the power of 10. Right, which is 1024. So that's not what I want. I want to be able to pass in 2 to the exponent and 10 to the base. So how might we do that? Well, we're just going to use here a named variable, right? So we're saying, no, 2 is going to go into exponent. So now you'll notice that what's missing when we're calling power is the first positional. So if we do that, and now we call square of, let's say, 5, we get indeed 5 squared, which is 25. And we can do the same thing. We can say cubic is partial POW comma 3, but we have to specify that it's the exponent that's going to be equal to 3. And so if we do cube of 5, we should get 125. Now, of course, because we're using named parameters, you could also just say cube base equals 5, right? And we still get 125. It's okay to make this a named parameter as well. You've got to be careful though, because there is one thing you can do. We can say 5 or base equals 5, and I can redefine what exponent is here. I'm going to make it 2. So now I'm actually going to square, not cube. And indeed we get 25 out. So you got to be careful, because what's happening is that this exponent equals 2 is essentially overriding what we had in the partial. So even though the partial has basically kind of hard-coded or predetermined the value of exponent, you actually still can change it if you want to after the fact. So it's not completely rigid that way. So it's actually pretty cool in some cases. The other thing too that I want to talk about is, we talked about that in the lecture, is the fact that if you use a variable, you've got to be careful, because the variable label isn't what gets input or gets baked into the partial. It's the reference of that label. What I mean by that is, let's say we have a equals 10. Well, let's say a equals 2, okay? And I'm going to make square equals partial of POW with the exponent equal to a. Okay? So now I can call square of 5 and we get 25. Now if I make a equal to 3, you might think, okay, well now if I call square of 5, that's going to give me 125, right? And the answer is no. It's still going to be 25 because what got baked into this partial isn't a, it's whatever a was pointing to, which happened to be the memory address where the integer 2 was living. That's what gets passed in, the reference. And we haven't changed what lives at that reference. Integers are immutable. We cannot change what lives inside that integer, right? We can change what a points to, but we cannot change the integer itself. So the partial will keep that 2. Right? So just something to be careful of, and it's really no different than when we were looking at default values for arguments in function calls. Now, if you have something that's mutable, that's different, and I alluded to that in the lecture. Let's try this out. So let's go ahead and write a small function again. We're just going to print. In this case, I'm only going to take 2 parameters, not 3. And I want to do a partial where I'm going to pre-specify what a is. And I'm going to pre-specify a, however, by using a variable, just like we did. So I'm going to set a equal to now a list, let's say 1 and 2. So a is a mutable type now. And I'm going to make f equal to a partial of my func, passing in a as the first positional. So basically, 1 and 2 is going to be in there. So if I call f of 100, I'm going to get 1 and 2, that list, and then 100. So now what I can do, I can say a.append, let's say 3, right? So if we look at a is now 1, 2, and 3. And if we call f again, the same way as before with 100, you'll notice that 1, 2, 3 is also showing up. And that's normal, right? Because partial is pointing to the object that a is referencing. We haven't changed what a references when we append. We just modified the object because it was mutable. We were allowed to do that. And hence, therefore, it shows up in the partial as well. So again, something to be careful of. Next, let's take a look at some applications of this and why we might want to be able to decrease the number of arguments that a function requires. For example, the sorted method, the sorted function in Python. Remember that sorted function? It allows us to sort a list, for example, and then we can specify a key. And that key argument is basically a function that's going to take in one value, one argument, which are the elements of the list we want to sort, and it's going to return a value that is then going to be used to determine the sort order of each element. And we've seen that before. So next, let's look at some examples of applying partials. And let's see why we may want to reduce the number of arguments that a function requires in order to be called. A very typical example is to sort. There is a built-in function in Python, we've seen it before, called sorted. And we want to sort things and a list, and we can specify a sort order. We can specify essentially another function that is applied to each element of the list that returns a value, and then that value is used as the sort key for the sorting. So what do I mean by that? Well, we've seen it before, but let's say that we want we have a bunch of points on the xy plane, right? We have a bunch of coordinates, xy coordinates, and we want to sort this list of coordinates based on their distance from the origin. So to work out the distance between 2 points, we need 2 arguments. We need point 1, point 2. Now in this case, point 2 is always going to be the origin. It's always going to be the 0, right? 0, 0, if you think of Cartesian coordinates. So this way, we can look at the distance between a point in our list and the origin as a function of really just one argument, not 2. So let's go ahead and do this. So we're going to define the origin as just the point 0, 0. So I'm just going to use a tuple. There's no need to create a class or anything fancy for this. We're just going to use tuples to represent xy coordinates. So origin is 0, 0. And let's say we have a list, 1, 1, and maybe 0, 2. I can type. And then -3 and 2. I really can't type. -3 and 2, okay, -3 and 2. Let's say we have 0, 0, we can have the origin in there itself. and maybe something further out, 10 and 10. Okay, so this is our list. It's just basically a list of tuples which represent xy coordinates. So now what's the distance between 1, 1 and 0, 0? Well, it's the square root of 1 minus 0 squared plus 1 minus 0 squared. Now, in order to do the sort, we don't actually have to use the distance. We don't have to have the square root. We can just use the unsquare rooted value. So 1 minus 0 squared plus 1 minus 0 squared, because the square root maintains sorting, right? So if a is less than b, then square root of a is going to be less than square root of b, and other way around as well. If square root of a is less than square root of b, then a is less than b as well. So it works either way. So let's define a function that's going to calculate the distance between 2 points. So let's call it distance squared equals lambda, and it's going to take 2 points, x and y. And how are we going to calculate that? Well, remember now, x and y are going to be tuples, right? X is going to be a tuple, y is going to be a tuple. So x is going to have its xy coordinate, y is going to have its xy coordinate. Maybe I should call this a and b. Okay, so a will have an xy coordinate and b will have an xy coordinate. So how are we going to do that? Well, we're just going to say x0, well, not x, now a0 minus b0 squared plus a1 minus b1 squared, right? That's going to be the square of the distance between 2 points in the Cartesian plane. So now we could look at distance squared, let's say, of 1 comma 1 and the origin, right? Which is 2, right? That would be correct. Well, if we have a right triangle, right, with side of 1, then the distance, the hypotenuse, is square root of 2, but in this case we have it squared, so it's just 2. So that's the distance. So we can use that to sort this list. How would we do that? We'd say sorted, and here we want to do what? Well, we want to sort L. Now, if we try and just do that, that's really going to not work according to how we want it. What it's going to do by default is going to look at, let's say, the first element of the tuple, right? And if the tuple is equal, then it's going to look at the second element of the tuple and so on. It's not quite what we want. We want to sort by the distance to the origin. So we need to change the sort order, and we can do that by using the key. So we'd say key equals. Now, key is what? Key needs to be a function that takes in a single parameter, which is going to be each element of the list. So if we try and use distance 2 and say, well, I want distance 2 of the element and the origin, that's not going to work because this isn't a function, right? This is a function call. It doesn't know what e is. Key has to be a callable. It has to be a function. So how are we going to do this? We just want to calculate the distance between whatever the point is and the origin. So we need some other function that's going to say, hey, calculate, distance from origin, right? And distance from origin should only take a single parameter, which is the point whose distance from the origin we want to find. So we can do that. We can certainly write a function that does that. But since we already have the distance function, why don't we use it? So let's go ahead and do it this way. Let's say dist squared. Well, actually, yeah, let's go ahead and say f equals partial distance squared. And now what do I want to do? Well, for the distance, I want to make one of those points equal to the origin. So yeah, okay, we'll make one of the points equal to the origin. So now we have a function f that really now only requires a single point. And when we do that, we again get that distance squared is 2. So you see that we were able to reduce the number of arguments that distance squared needed down to 1. So now we can actually call f. We can use f here because f is a single thing. So if we do that, we now get the thing sorted in the order that we want. 0, 0 is the closest to the origin, then 1, 1, then 0, 2, then negative 3, 2, and then 10, 10. So that achieves what we wanted. But we wouldn't have been able to do it had we not reduced the number of parameters that distance 2 needed. Now, obviously, you could have done it using a lambda, for example. You could have said lambda x, and it's going to return distance squared of origin comma x. Okay, we could do that as well, and you would get the same effect here. All right, we get the same sort order. The other thing too I want to point out is that you don't have to assign it to F. So you could also do this, sorted L, key equals partial, or you could use lambda as well. You could say key equals lambda x, distance squared origin x. You could just type this right in here. Okay, so we could do it this way. That will work as well. Or you can just use whatever we used here and type this in here, like so. And this will work equally well. Thanks for watching, and I'll see you in the next video.